Hi Roselle, I got your email about the video here. Just hang on. Sorry, as soon as I make a video, somebody walks in the door and starts talking to me. All right, so let's try that again. Oh, what happened? Turn it on. All right. So with L'Hopital's rule for this, what we're doing is taking the derivative of the top and the bottom independently, and then writing the derivatives in fraction form. So if you think about what's going to happen, what they're doing at the top there is treating the x like a constant, like just an exponent. We're not treating this like an exponential where we would have to take the derivative differently. We're just treating it like if we had like x cubed, then the derivative would be 3x squared. Okay, so if we look at the negative b to the x like that, where all we do is we bring, the exponent comes, in front, and then we do 3 minus 1 to get the new exponent, where we're subtracting 1 each time, then let's look at that way, and I think it'll make more sense to you what they're saying. If we do the first derivative, we end up with negative x times b to the x minus 1 using the derivative rule that I was just talking about over here. And then, of course, e to the b is just going to stay as e to the b no matter how many times we do it. So if we keep going with that idea, then we're going to end up with, the next time around, it's going to be negative x times x minus 1 times b to the x minus 2 over e to the b. And if we do that again, then we're going to end up with negative x times x minus 1 times x minus 2 to the b, or times b to the x minus 3 over e to the b, and so on. So you can kind of see how this is taking the factorial shape, right? Like this part here is n times n minus 1 times n minus 2, and so on and so on. And so eventually, if you do it enough times, you're going to end up with negative x factorial for the sort of coefficient of the derivative of b to the x. And then, of course, your exponent here is always going to be, b to the x, but it's always a different value of x that we've got there. And so that's why he's generalizing and saying that when you get down to infinity, then we end up with this becoming b to the 0. That's the limit of that as x approaches infinity. And then that's equal to 1. So that would be 1 times minus x factorial. And so that's where he came up with the final sort of version of L'Hopital's rule for the value of that uv part of the integral. And then he's moving on from there to make the generalization. So I hope that helps explain it. That's what he's doing, and that's pretty high level for the point that you're at with the calculus right now. So, I think it wouldn't be a bad thing if you can't, fully 100% understand that and explain it in your own words, for you to say, I watched a video that explained this, and this is what I get from it. It's from the part I can understand is this, and that's why we arrive at this. I think that would be fair. If you can understand it, or we can talk about it some more tomorrow morning, then you can definitely use that as part of your solution as long as you understand it.